All right, so today is graphing techniques. We're going to do transformations. So we're going to jump right into this, and I'm going to try to keep this a little shorter than how long it lasted in class. All right, so first off, we are going to do a vertical shift up or a vertical shift down. So the easiest way we're going to do this, we're going to look at the function that is given. So we are given x cubed. So I'm going to take the x values that are given, I'm going to plug them in and get the f of x or y values. So negative 2 cubed is negative 2, negative 2, negative 2, which is negative 8. And this is writing way too chunky. All right, negative 1 squared is negative 1, 0 cubed is 0, 1 cubed is 1, and 2 cubed is 8. All right, so now, if I were to shift this plus k, or plus 2 units, this is going to be going up. So I'm going to take the x cubed that I just found, and I'm going to add 2 to all of my numbers. So negative 8 plus 2 is negative 6. Negative 1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is 3. And 8 plus 2 is 10. All right, and then in this next box, it says to take your x cubed and shift it down. So we're going to shift it down. All right, what is this thing doing? All right, so I'm going to take my x cubed. I'm going to take this box over here again, and I'm going to subtract 2 from everything. So negative 8 minus 2 is negative 10. Negative 1 minus 2 is negative 3. 0 minus 2 is negative 2. 1 minus 2 is negative 1. And 8 minus 2 is 6. So now I'm going to come over here to the graph. I'm going to graph it and just see what it looks like. So starting with the original, so I have negative 2, negative 8, negative 1, 0, 0, 1, 1, and 2, 8. So this will be the original graph. So this is our graph of f. All right. I'm going to do the graph of g. So negative 2, negative 6. Negative 1, 1, 0, 2, 1, 3, and 2, 10. And now this one is going to look like this. So here's our graph of G. And then last, I'm going to graph the shift down. So we got negative 2, negative 10, negative 1, negative 3, 0, negative 2, and 1, 1, or 1, negative 1, sorry, and 2, 6. And so again, I'm going, let's try this way. There we go. So there's our graph of H. So you can see from the parent function, x cubed, this was our 2 shift up, this is our 2 shift down. So what you're doing is you are taking, so what you should observe is you're taking your original values. Okay, what is this thing doing? And the x value is staying the same, and I am taking the y value and adding something. This is our shift up, and y minus k is our shift down. All right, so the next we're going to talk about a vertical stretch. So I am going to quickly highlight the rules real quick. All right, so now we're going to talk about a vertical stretch. So a vertical stretch is when you take your function and you multiply the whole function by some number a that's greater than 1. So for starters, we are going to go back and we're just going to plug in the x values into our function, absolute value of x. So the absolute value of negative 4 is 4. The absolute value of negative 2 is 2. The absolute value of 0 is 0. The absolute value of 2 is still 2. And the absolute value of 4 is still 4. Remember, the absolute value just means your answer is absolutely positive. All right, so now we're going to take the absolute values that we got in this column here, and we're going to multiply them by 2. So 4 times 2 is 8. 2 times 2 is 4. 0 times 2 is 0. 2 times 2 is 4. And 4 times 2 is 8. And I'm going to do the same thing again. What if we had what's called a shrink? So this is a vertical shrink. This is where you take the function and you're still multiplying by a, except this time a is less than 1, but has to be greater than 0. So now we're going to take those same values and we're going to take half of them. So half of 4 is 2. Half of 2 is 1. Half of 0 is still 0. Half of 2 is still 1. And half of 4 is still 2. And now I'm going to come over here and I'm going to look and see what happens. So starting with the original, we have negative 4, 4. We have negative 2, 2, 0, 0, 2, 2, and 4, 4. So if you notice, you've got a graph that looks like a V. So there is your parent function or the original function. All right, now we're going to do the vertical stretch. So the vertical stretch points are going to be negative 4, 8, negative 2, 4, 0, 0, 2, 4, and 4, 8. So this is your vertical stretch. My lines are not very straight. And then last, we are going to do the vertical shrink. So the shrink is negative 4, negative 2, negative 2, 1, 0, 0, 2, 1, and 4, 2. And again, draw your lines. So this is our graph of H. So if you notice the vertical stretch, the graph became more narrow, and the vertical shrink, the graph became more wide. All right, so what does that mean in terms of the points? So if you look, our x values and our y values, so the x values stayed the same. The y values are multiplied by a. So that is the number that is shrinking or stretching. All right, reflection. Reflection about the x-axis. So we're going to take the square root. So the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. Now, a reflection over the x-axis, basically what's happening here is you have the negative sign that's going to go in front of the answer to that. So now you're changing the y values, okay? So the absolute value, the square root of 0, so negative times the square root of 0 is still 0. The square root of 1 times negative is negative 1. The square root of 4 is 2 times negative is negative 2. The square root of 9 is 3 times the negative is negative 3. So what you should observe here is when you take your original points, what's happening is x stays the same, but the y values are changing. So when you reflect over the x-axis, your y values will change sign. So they will go from positive to negative or negative to positive. So if I come over here and graph the points, so 0, 0, 1, 1, 4, 2, 9, 3, There's your graph of the square root of x. Negative square root of x is 0, 0, 1, negative 1, 4, negative 2, and 9, negative 3. So here is your F, and here is your G. So it reflected. So you just folded it along the x-axis, and it copied. All right. So we have all of our rules. Now let's go and look at horizontal transformations. So a horizontal transformation, so we're going to have a shift left or a shift right. So you're moving along the x-axis, so you're moving left and right. Please note that when you are shifting, this is a shift left because basically what you have is x minus some number. If it's a negative number, which indicates moving left, a negative number indicates that it's a double negative, so it becomes positive. So make yourself a note here that inside the parentheses is always going to be opposite. So x plus h is a move left, x minus h is a move right. All right, so let's see what happens when we find the points. So we're doing x cubed again. This time they're giving us the y value, so we're going to have to find x. So if you think about what's going on here, we're saying that the answer, f of x, is equal to x cubed. So negative 8 is equal to x cubed. The opposite of cubing is to take the cube root. So I have to take the cube root of both sides. If I take the cube root of x cubed, it's x. The cube root of negative 8 is negative 2. So we're just going to work backwards. So you do the same thing. The cube root of negative 1 is negative 1. The cube root of 0 is 0. The cube root of 1 is 1. And the cube root of 8 is 2. So now we're going to do the exact same thing with the g of x, which says x plus 4. So we know this is going to be a shift left. So I'm going to do negative 8 equals x plus 4 cubed, because that's what my function is x plus 4 cubed. Still have to do the same thing. I have to take the cube root of both sides. I already know the cube root of negative 8 is negative 2. When I take the cube root of a cube, it's just what's inside. And then I have to subtract the 4, which is your move left. So x is negative 6. So take the cube root and then move left 4 units. So the cube root of negative 1 is negative 1. Negative 1 minus 4 is negative 5. The cube root of 0 is 0. 0 minus 4 is negative 4. The cube root of 1 is 1. 1 minus 4 is negative 3. The cube root of 8 is 2. 2 minus 4 is negative 2. And then the same thing here. We're going to take our negative 8. We're going to set it equal to x minus 4 cubed. And just like before, we have to take the cube root to get rid of the cubed. So the cube root of negative 8 is still negative 2. The cube root of x minus 4 cubed is x minus 4. So now we're going to add the 4, which indicates moving right. So x is negative 4 plus 2, negative 2 plus 4 is 2. So now we have a 2 here. So take the cube root and add 4 because we're moving right. So the cube root of negative 1 is negative 1. Negative 1 plus 4 is 3. The cube root of 0 is still 0. 0 plus 4 is 4. The cube root of 1 is 1. 1 plus 4 is 5. The cube root of 8 is 2. And 2 plus 4 is 6. So now we can plot the points and see what those graphs are going to look like. So starting with our original point here, we've got -2, -8, -1, -1. I totally went backwards on that. Let me start over. Starting over. All right. -2, -8. -1, -1. 0, 0, 1, 1, 2, 8. So again, we have that curvy graph. So there is our function. Now we're going to shift to the left. So we're going to do the x plus 4. So now we've got -6, -8, -5, -1, 0, -4, -3, 0, -3, 0. Oops. I am plotting these points all crazy. Go back. -5, -1, -4, 0, -3, 1, -2, 8. All right. Sorry about that. These graphs are killing my eyeballs. All right. So there's your G. And if you notice, this was a shift left. We took our original graph and we went to the left, -4. All right, and then our shift right should take all the points to the right. So 2, -8, 2, -8, 3, 1, -1, 4, 0, 5, 1, 6, 8. So now we have the exact same graph. It's the same size, nothing's different. This time we went +4 units to the right. So what is the rule as far as taking your original points and your y values or your x values, like what we've been doing? So if you take the rule of shifting to the left, so you start out with your original, and you take your x values and subtract 4, and our y values stayed the same. If we shift to the right, we're going to take our original point, xy, and we're going to add 4. So here, if you think about it in terms of not always just adding 4 or subtracting 4, so if you think about it, you're subtracting and adding the h, so x minus h, x plus h. So those are the rules for moving your points. All right, a horizontal shrink and a horizontal stretch. These two, I think, are maybe the most confusing. A horizontal shrink and a horizontal stretch. And then we have those parameters. So the parameters for a shrink is that your a value has to be bigger than 1. So it's kind of the opposite again, if you think about it. A has to be bigger than 1, but you are shrinking. And the way that works is you take the A and you place it under a 1. And I'm going to show you what that looks like, okay? So let's just go ahead and get the absolute values. We got to find the x's again. So the absolute value of 4. So I know that 4 is equal to the absolute value of x. Well, there are two answers because I can plug in a -4 or a +4. The absolute value of -4 is 4, and the absolute value of +4 is 4. So I'm going to get a -4 and a +4 when my answer is 4. The same thing's going to work for 2. -2 and 2, and then 0. So the absolute value of 4 is -4 and 4. The absolute value of 2 is -2 and 2. The absolute value of 0 is still 0. Now we're going to do the same thing over here. So we've got 4 is equal to the absolute value of 2x. Well, I need to divide both sides by 2. Now I've got 2 is the absolute value of x. Well, here we go. What is the absolute, what numbers can you plug in for x that will give you 2? So x can be plus or minus 2. So the absolute value of 4 when it's 2x, this is -2 and a +2. This time notice that you went from 4 and 4 and now you took half. So what you're doing is you're multiplying, your shrink is basically you're multiplying by 1 over 2. So a horizontal shrink is multiplying by 1 over a. So this one would be -1, 1, and 0. Now, a horizontal stretch is when the a is between 0 and 1. So it's actually less than 1, but it's a stretch because you're actually going to multiply by 2. So if you think about -4 is equal to the absolute value of 1/2 x, I'm going to multiply both sides by 2. So if I multiply by 2, that cancels. If I multiply this side by 2, I get -8 equals the absolute value of x. Well, if the absolute value of x is -8, so that could be a -8 or a +8 when you plug that -8 in. So if I plugged in the absolute value of -8, I get 8. So this is going to be -8 and this is +8. So I can plug in -8 and I'm going to get a +4 because your answer always has to be positive. So take half of all the numbers, or not take half. When you're multiplying by half, you're doubling. I know, it's confusing. So if I multiply both sides by 2, I get -4 and 4. And if I multiply by 0, I still get, or I multiply by 2, I still get 0. So that's how you do those, okay? So the rule, so let me go over here to the side. When you are doing a vertical or a horizontal shrink, so I'm going to write a horizontal shrink. You are taking 1 over a. In this case, it's 1 over 2 because our a, in this problem, our a was 2. So you're multiplying by, just make the reciprocal. Here, our a is 1/2. Well, if I did 1 over 1/2, that's just 2, which is why we multiplied both sides by 2. So just remember, a horizontal shrink is 1 over a. A horizontal stretch is the 1 over a. But your fraction is going to flip. So you're going to flip your fraction or do the reciprocal. All right, so let's plot the points where we can see what they look like. So starting with our original graph. So we've got -4, 4, -2, 2, 0, 0, 2, 2, and 4, 4. So this is our graph of f. The shrink is -2, 4, -2, 4, -1, 2, 0, 0, 1, 2, and 2, 4. So a horizontal shrink is actually a shrink. It actually is getting narrow. And a horizontal stretch, so now we've got -8, 1, 2, 3, 4, -4, 2, 0, 0, 4, 2, and 8, 4. And a horizontal stretch actually looks like a stretch because it looks like it's stretching out. All right, so what does that look like as a rule? So as your rule, your xy is going to be 1 over a x and your y. So 1 over a times your x will get, and then your y will stay the same. All right? So that one you may have to practice a little bit. To me, it's the most confusing, and I hope I didn't make it worse. All right, a reflection. So a reflection over the y-axis. This time, notice that the negative sign is inside the parentheses. So again, when you are inside the parentheses, it's always going to be opposites. So here, when you are flipping, reflecting over the x-axis, when you're flipping over the, we flipped over the x-axis, the y values changed. When you flip over the y-axis, the x values change. So x values will change signs. So this time your xy will be negative x, y. So let's fill out this chart. So the absolute value of 0 is 0. Oh, we're plugging in, sorry. So I got to work backwards again. These are not your x values. These are what your answer is. So if I were to think about 0 is equal to the square root of 0, the opposite of square root is to square. So the square root of 0 squared is 0, and 0 squared is 0. So if I square both sides, so the square root of x squared is x, and the square root in 1 squared is 1. Same thing here. If I square both sides, sorry, I should have put this here. So if I square a square root, it's just x, so 2 squared is 4. And the same thing here. We are going to square both sides, so 3 squared is 9. So you have to work backwards. All right. Now over here in this column, it's going to look a little different. So if you think about, this one's going to be 0 because the square root of 0 is 0, negative 0, it's all 0. So let's start with the 1. So we know that the square root of negative x is 1. So we know that it equals 1. So you have to square both sides, and you get negative x equals 1. Well, if negative x equals 1, then positive x equals negative 1. So if I plug in a negative 1 into this formula, I will get a positive 1. All right, same thing with the 2. So now I'm going to enlarge this just a little. So now I've got 2 is equal to the square root of negative x. So I'm going to square both sides. So I get 4 is equal to negative x, so x is negative 4. Same thing with the 3. It is going to be negative 9, because if you notice, you are following the rule. So let's plug in and see what it looks like really quick. We got 0, 0, we got 1, 1, we got 4, 2, we got 9, 3. And this time we're reflecting over the y-axis. So we're going to flip it over the y-axis, so it should move over to the second quadrant. So this is our F. Oops. This is our F. And then we've got 0, 0, negative 1, 1, negative 4, 2, and negative 9, 3. So this one is going to look like that, and that is your graph of G. And that is a vertical or flip over the vertical y-axis. All right, this page is just all your rules lined up in one place. So all your vertical changes here, these have to do with your y values changing. And your horizontal, which is on the where everything's on the inside, or where your x values are going to change. So remember, a reflection over the x-axis is x stays the same and the y changes. A reflection over the y-axis is your x's will change, but your y will stay the same. So whatever axis you flip over, that one stays. The other one changes. A horizontal stretch or shrink, remember this is your reciprocal or your flip. Let's see. So this rule is going to be x, y plus or minus k. This one is going to be x plus or minus h, y. And then your stretch or your shrink is x stays the same and you multiply your y times a. And this one is going to be 1 over ax y. So those are the set rules for how the points change and how it graphs different. Here are some examples of inside and outside. You take anything. This is going to be a shift up. This is going to be a vertical stretch. This is going to be a reflection over the x-axis. And then when you go to the inside, now you're shifting to the right. This one is a horizontal stretch or shrink, and then this one is a reflection over the y-axis. So pay attention to the inside outside because that'll tell you if you're vertical or horizontal. Oops. All right. So now let's look at these points. These are just some points that have given. We're not looking at an actual formula. We're just going to talk about, okay, they want me to do whatever function this is, our little graph over here. They're wanting me to x minus 4 plus 3. So take the function. So if it's minus 4, that means we're going to add 4 to the right, and then we're going to go up 3 because inside the parentheses is moving the x-axis. Outside the parentheses is doing something with the y-axis. So I'm going to add 4 to all of my x values. I'm going to add 3 to all of my y values. So if I do that, negative 4 plus 4 is 0. Negative 2 plus 3 is 1. 0 plus 4 is 4. 2 plus 3 is 5. 2 plus 4 is 6. 2 plus 3 is 5. And 4 plus 4 is 8. And 0 plus 3 is 3. So now I've got my new points. And I can graph those new points and compare it to the graph that I have here. So if I graph 0, 1, 0, 1, 4, 5, 6, 5, and 8, 1, 2, 3. And I took the graph and I just went to the left 4 and went up 3. All right, next. This has a negative out front, which means reflect over the x-axis. So the negative is reflect over the x-axis. And the 2 on the inside is a horizontal shrink. So since it's the horizontal shrink, that's the 1 over a. And since my a is 2, this is a horizontal shrink of 1/2. So horizontal is your x-axis, and we're going to reflect over the y-axis or x-axis. So this is x and then this is 1/2 x y. So we're going to combine those two rules, and we're going to get our new rule. So that's going to be 1/2 x minus y. So I'm going to take half of all my x values, and I'm going to change the sign of my y values, and I have my new points. Half of -4 is -2. Change the sign of -2 to 2. Half of 0 is still 0. Change the 2 to a -2. Half of 2 is 1. 2 becomes -2. Half of 4 is 2. And 0 is still 0. So now I can plot this points and see what it looks like. So -2, 2. 0, -2. 1, -2. And 2, 0. And that's what it looks like. We reflected over the x-axis because up here, if you look, you can see that it is now upside down. And then we shrunk it by a half, so it's also smaller. And you can check that because you can look at this part right here where this is 2 units long, but this is only 1 unit long because it's half. So we shrunk the length of the sides. All right, the last one, there's a lot going on in this one. There's 3 things. We have the 3 in the front, which means it's going to be a vertical stretch. So I'm going to come down here. So we have a vertical stretch. By 3. So that's going to be x 3y. Then we have the negative inside, which is a reflection over the y-axis. So now the negative on the inside is going to be a reflect over y-axis. So that's going to be -xy. And then we've got this -1 right here, which is going to be a vertical shift down. So that rule is going to be x and y minus 4. So if I combine all of these rules together to get my new set, I have x, x, and -x, so it's -x. I have 3y, y, and y minus 4, so this is going to be 3y minus 4. And now I can get my new points. So I'm going to change all the signs of the x values. So this is going to be 4, 0, -2, -4. So I'm just changing the signs of the y values, or the x values, sorry. And then I'm going to take the y values, I'm going to multiply by 3, and then subtract 4. So -2 times 3 is -6. -6. Oh, why did I put 4? This is a, see, I told y'all we did that 4 a while ago and I got stuck. That's going to be a 1, not a 4. So -2 times 3 is -6. -6 minus 1 is -7. 2 times 3 is 6. 6 minus 1 is 5. 2 times 3 is 6. 6 minus 1 is still 5. And 0 times 3 is 0. 0 minus 1 is -1. So now I can plot these points, and we can see that we've reflected over the y-axis and shifted down. So we've got 4, -7. So 4, -7. I'm going to enlarge this where I can see these better. 0, 5, 0, 5. -2, 5. See, it's still the same length, that length of 2, so it didn't change sizes. And then we've got -4, -1. So we did the vertical stretch. So it stretched vertically, not horizontally. And then we reflected. So the longer side is now on the opposite side. And we went down also. So that's what it would look like. So using the rules to me are super helpful. Like if you can take what you're doing and convert it into a format, then it kind of helps. All right, so let's just do these last ones. So starting with, oops. All right, so starting with f of x, we're going to convert it to g of x. So let's describe the transformation. So the first transformation is there's a vertical stretch by 2. So a vertical stretch by 2. So that's going to look like x to y. And then we have the plus 1 on the inside. So that's a horizontal shift left by 1. I clearly can't spell. So this is going to be x minus 1 y. So that's what each one of those rules are going to look like. You combine the two rules together and you can get what's going to happen. So we're going to have our original points and then we're going to turn it into x minus 1 to y. All right, let's do 0, 0, 4, 2, 9, 3, and let's do a negative 4. No, let's just stick with these 3 points. All right, so let's convert them. So 0 minus 1 is minus 1, and 2 times 0 is still 0. 4 minus 1 is 3. 2 times 2 is 4. 9 minus 1 is 8. 3 times 2 is 6. So there's your new points. So if I take and plot them, I've got, I have to enlarge this where I can see it. We've got 0, 0. We've got 4, 2. We've got 9, 3. So there is our graph here. And then our new set of points is negative 1, 0, 3, 4, and 8, 6. So there's your F, there's your G. So if you can tell, it shifted backwards 1, so there's your shifting backwards, and then it got 2 times bigger. All right, let's look at the next one. So looking at our f of x, which is x squared, and our g of x, we're going to have a reflection because we have a negative in front. And then we've got a 2 on the inside, so that's going to be a horizontal shift. So the first thing we have is a reflection over the x-axis. So reflect over x-axis. So when we reflect over the x-axis, the y values change. So that's going to be that rule. And then we have the horizontal shift. Since it's negative there, it's going to be right by 2. And this rule is going to be x plus 2, y. So if we combine our two rules together, starting with our original x, y, our new rule is going to be x plus 2, negative y. So if we start with negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. All right, and our new rule is going to be to add 2 and change the sign of the y. Add 2, change the sign of the y. Add 2, zeros don't have signs. Add 2, change the sign of the y. add 2, change the sign of the y. So it goes really quick if you think about it that way. All right, so let's plot the points really quick. -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. So that is a curve, not an absolute value. That's a terrible. All right. And then the next set of points is 0, -4, 1, -1, 2, 0, 3, -1, and 4, -4. And there is your G. So we shifted it to the right and flipped it over. All right. This time we've got a lot. So we take our absolute value of x and we turn it into g of x. So we have a negative, which means there's a reflection. We have a 1/3, which means a horizontal stretch or shrink. And then we've got the +2, which is going to be the vertical shift. So the first thing is we have a reflect over the y-axis. So that means that x changes. Then we've got the horizontal stretch by 3 because this is the 1/a thing. So this is your horizontal stretch by 3 because 1/1/3 is 3. So that's a horizontal, so that means multiply your x's by 3. Your y's don't change in this one. And then our third rule is to vertical shift up by 2. So that's going to be x, y plus 2. Now combine all 3 of your rules together. So take our original x, y. So we got -x, 3, and x. So this is going to be -3x. Y plus 2. So y plus 2 is our rule. So now let's get some points. So we start with -3, 3, -2, 2, -1, 1, 0, 0, 2, 2, and 3, 3. So remember, you're doing absolute value, so your y values are always going to be positive because the outcome has to be positive. All right, so now let's do the magic here. So -3 times -3 is 9. -2 times -3 is 6. -1 times -3 is 3. 0 times -3 is 0. 2 times -3 is -6. And 3 times -3 is -9. So there is our new x values. It's kind of easier to me if maybe you do it that way. 3 plus 2 is 5. 2 plus 2 is 4. 1 plus 2 is 3. 0 plus 2 is 2. 2 plus 2 is 4. And 3 plus 2 is 5. So there's all of our new points. And slide over and graph them quick. Maybe. All right, -3, 3, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, and 3, 3. So absolute value is always that V. All right, and then our new set of points, 9, 1, 2, 3, 4, 5, 6, 4, 1, 2, 3, 4, 3, 3, 0, 2, -3, 3, -6, 4, -9, 5. So you can actually see how you reflect reflected over the y-axis, which there's really not a big reflection when you're doing absolute value because it's just straight lines on either side. But we reflected over the y value, or the y-axis. We did a horizontal stretch, which means it got 3 times wider, and we shifted up 2, which you can see the shift up 2 here. All right. So now, what if I tell you, here's your function. I want you to tell me what it should look like. So I'm going to take my function, the square root of x, and I'm going to shift it up 2. Well, that's going to look like this. And then if I want to reflect it about the y-axis, so if I'm reflecting over the y-axis, that means x changes. So if that means negative x goes inside. So now you've got these 2 rules. So your g of x is the square root of negative x plus 2. So you've got your shift and your reflection. All right, so here we go. We got x squared, and we're going to shift left. So if we're shifting left, that means you're adding 5 because minus a negative. So this is going to be x plus 5 squared. And we have a vertical compression by a factor of 1/3. So vertical means it's outside the parentheses, so you don't have to worry about the a, 1 over a, because it only applies to horizontal. So our final statement is 1/3 times x plus 5 squared. All right. Well, what happens when we got 3 things going on? So starting with x cubed, we have a horizontal stretch by a factor of 9. The horizontal stretch means 1 over a, so that's 1 over 9. So that is going to be 1 over 9x cubed. Now we're going to reflect over the x-axis, which means the y value changes, so now it's outside the parentheses. And then we're going to shift down 7 units, so you're going to subtract 7 from everything else. So your final answer, g of x is equal to negative 1 over 9x cubed minus 7. All right, last. So we're going to take our square root of x, our absolute value of x, and we're going to shift right. So if we're shifting right, that means we're doing x minus 6, and it has to be inside. A vertical stretch just means you're multiplying by 3, so it's on the outside because it's a vertical. So this is 3, x minus 6. And then we're going to shift down 4, so you're going to subtract 4. So our final answer, g of x is equal to vertical shift, vertical shift. So vertical stretch, horizontal shift, and then a vertical shift. Now, what if you rearrange those? What if you do them in a different order? So what if we shift right again? So this is still x minus 6. Now we're going to shift down. So this is going to be x minus 6 minus 4. Now, after we do that, then we're going to do a vertical stretch by 3. So now you're going to take 3 and you're going to multiply by the whole thing. So now your final statement is x minus 6. So we got the 3 times x minus 6 minus 12. So we're actually going to move down 12 because our vertical stretch by 3 takes our shift down and multiplies that by 3. So it becomes a shift down of 12. So this is your final answer. So I hope that helps. If you have any questions, please make sure you're ready for your questions tomorrow. And I will see you guys then. Bye.